In this video, I want to show you 3 ways to solve linear systems. Remember that a linear system is when we have 2 lines, and we want to know where these lines cross each other. We need to find the x-coordinate and the y-coordinate of that point. There are 3 ways we can do this, and all of the ways will give us the same answer. The first way we might use is called comparison. So, for an example, let's say that we have 2 functions, y equals 2x plus 4, and we also have the function y equals 4x minus 2. Comparison is really handy in this case because both equations are already solved for y. That is, we have y on one side of the equation and everything else on the other. When we have equations that are both written in this form, comparison works well. What we do is we compare the ax plus b portion of one function with the ax plus b portion of the other function. We can ignore the y's. What that looks like is this. We would write 2x plus 4, so the ax plus b from the top function, equals the ax plus b from the bottom function, 4x minus 2. Now look what we've done. We've rewritten this so that we only have x's in our equation. We have no y's. Because we have x's, we can think about solving this for x. To do that, we want all of the x's on one side and all of the numbers on the other side. So we can subtract 2x from both sides. We're left with 4 on this side because 2x minus 2x is 0. So we still have our 4 equals 4x minus 2x is 2x, and we still have this negative 2. We want the x's by themselves, so to get rid of this minus 2, we'll add 2. 4 plus 2 is 6 equals 2x, and the 2's cancel each other out. We want to know what x is, not 2x, so we can divide both sides by 2, and we're left with 3 equals x. Now remember at the beginning, I said we want the x-coordinate and the y-coordinate. Right now, we only know the x value of where these lines cross. To find the y value, we can take either of our 2 initial functions and substitute in 3 instead of x. So let's take the top one. We had y equals 2x plus 4. We know now that x equals 3 when these lines cross each other, so we can replace our x with 3. We'll get y equals 2 times 3 plus 4. And if we solve this, we get y equals 2 times 3 is 6, plus 4, or y equals 10. Therefore, our solution is the point 3, because x equals 3, comma 10, because y equals 10. So that's the first method of solving linear systems, comparison. We could use another method, and this other method is called substitution. This works really well if one of the functions is solved for x or for y. That is, if x is by itself on one side of the equation and everything else is on the other side, or if y is on one side of the equation and everything else is on the other side. So an example might be y equals 3x minus 2. And for our second equation, maybe we have 4x minus 2y equals 6. So see how this top function already has y by itself, and then ax plus b on the other side. What this means is that y is the exact same thing as 3x minus 2. So if we start with our second equation, 4x minus 2y equals 6, we can replace this y with the value 3x minus 2, because y is the same thing as 3x minus 2. So I'm going to rewrite everything in this equation exactly as it is, but instead of y, I'll write 3x minus 2. So it would look like this. 4x minus 2 Now instead of the y, I'll write a brackets and write 3x minus 2. And then everything else remains the same, equals 6. Now this equation only has x's in it instead of both x's and y's. Because I only have one variable, I can solve for that variable. So I can do 4x minus 2 times 3 is 6x. Negative 2 times a negative 2 is a plus 4. Then equals 6. And now I can think about combining my x terms. 4x minus 6x is a negative 2x. And we still have our plus 4 equals 6. Now I want all of the numbers on one side, so we can get rid of this 4 here by subtracting it from both sides. We're left with negative 2x equals 6 minus 4 is 2. To get x all by itself, we'll divide by negative 2. What we're left with then is x equals negative 1. Just like in the first case, we don't just want our x value, we want our x value and our y value. So we can take either of our first two equations and substitute our x value in, just like we did when we were using comparison. So let's take this top equation. Y equals 3x minus 2. Well, we know in this case now that x equals negative 1, so y equals 3 times negative 1 minus 2, and now we can solve. Y equals 3 times negative 1 is negative 3. We still have our minus 2. We can combine our numbers. Y equals negative 3 minus 2 is negative 5. So our solution is x is negative 1, y is negative 5. So that's how you use substitution. The last method we might use is called elimination. This method works really well, but what we have to make sure is that in both of our functions, the x, the y, the equal sign, and the number all appear in the same order in both equations. So let's look at an example. We might have the function 3x plus 2y equals 5. And let's say our second equation is 4y equals 9x minus 5. Now in this case, we see we have an x first, and then a y, then our equal sign, and then our number. And in our second one, we have y first. So already this poses a problem. We would need the second one to have x first, then y, then equal sign, and then our number. But what we can do is we can reorder one of these functions. And it doesn't matter which one, so long as at the end, everything's in the same order. So let's change our first function. We have 3x plus 2y equals 5. We want our y's on one side, so let's leave this where it is. And we can subtract 3x from both sides. So then we'll have 2y equals, let's write our x's first, because they came first in our other equation. So minus 3x, and then we still have our plus 5. So we've changed our first equation to 2y equals negative 3x plus 5, and our second equation was 4y equals 9x minus 5. Now, let's write these one on top of the other. So we have 4y equals 9x minus 5, and we have 2y equals negative 3x plus 5. So now we see that these are in the same order. Our y's comes first, then our equal sign, then our x's, and then a number. The next thing we have to do in elimination is make sure that we have one pair of identical coefficients. What I mean by that is that the number that comes right before the y needs to be the same in both equations, or the number that comes before the x needs to be the same in both equations. We don't have that, but we can make that happen. What we can do is multiply the top equation by the coefficient on our y. So our coefficient, the number before our y, is 2 here. So we're going to multiply everything in our top one by 2. And we can multiply everything in our bottom equation by the coefficient that's in the top one. So we're just multiplying by the opposite coefficients. We'll multiply by 2, and down here we'll multiply by 4. When we do that, we end up with 4 times 2 is 8, so we have 8y. 9 times 2 is 18, so it equals 18x. Minus 5 times 2 is minus 10. This one, we'll multiply everything by 4. So we'll get 2 times 4 is 8y equals negative 3 times 4 is a negative 12x, and 5 times 4 is 20. I'm going to write an equal sign here, because what we're going to do is we're going to subtract one function from the other. And I put this little subtraction sign here just to remind myself that everything has to be subtracted. So 8y minus 8y is 0. So I'm going to write a 0 here, equals 12x minus a negative 12x. This is where we really have to be careful with our signs. So we have 18x minus a negative 12x, which will be 30x. And then negative 10 minus 20 will be minus 30. We want x's on one side, numbers on the other. So let's add 30 to both sides. We'll end up with 30 equals 30x. If we divide everything by 30, we'll get 1 equals x. Just like before, we want the x value and the y value. So we can take either of our equations, and I typically go back to the first equations, but it doesn't matter. We can go to the revised one or even these two. And we're going to replace x with 1. So let's take this top one here. We have 3x plus 2y equals 5. We know that our x is 1. That's what we just found down here. We can replace our x with 1. 3 times 1 plus 2y equals 5. 3 times 1 is 3, plus 2y equals 5. We want to isolate our y's, so we'll subtract 3 from both sides. We'll get 2y equals 5 minus 3 is 2. Divide everything by 2, and we'll find that y equals 1. So we know that y equals 1, and we know that x equals 1. So our solution is x is 1, y is 1. So those are 3 methods you might use to solve a system of linear equations. They all work, and my preference just depends on how my equations are set up to begin with. Hope that helps.